Hello, in this question we're going to go over a parametric equation from the OCR A specification from 2018, question 10, so it's towards the end of the pure part of that paper. I suppose the most tricky part is at the end, but to find a Cartesian of a relatively kind of involved parametric, so it's a little bit tricky, but they give us quite a bit of help with it, so it's not too bad. Anyway, first bit is to find dy by dx, which is no real problem. We need to find individually dy by dt and dx by dt. Dx by dt, let's write it in power form. Differentiate t with respect to t, you get 1. Differentiate this times by the minus 1. Take 1 off the power, that's 2. T to the minus 2. So that's equal to 1 minus 2 over t squared. And then y equals to t minus 2t to the minus 1. Similar thing. So dy by dt is equal to 1 plus, because there's 2 minuses there, times it by the minus 1 gives us plus 2. Taking 1 off the power is 2t to minus 2. Which is equal to 1 plus 2 over t squared. Right, okay, so then with this one now we can find dy by dx, which is basically this divided by this, dy by dt divided by dx by dt. Which is equal to 1 plus 2 over t squared and 1 minus 2 over t squared. Now it's asked for simplest form, so this definitely wouldn't qualify as simplest form as it is a stacked fraction like that. I don't think it would be also any good with indices either. They'd want, if we wrote the indices, that's not going to help. Not like an indice on top of indice. Hopefully we can simplify this easy enough. Just times by t squared on top and bottom. And we're going to get, this is going to be t squared, but here the t squared will cancel. This is going to be equal to t squared here, but the t squared will, whereas in this bit here the t squared will cancel, and you'll just end up with minus 2. Okay, so that's again not too bad. So we've got dy by dx, it's not too bad there. Then there's a little, they like these questions where it gets you to interpret this and say why there's no stationary points. A stationary point would imply, happens when dy by dx is equal to 0. Okay. And the thing is, that would mean that t squared plus 2 over t squared minus 2 equals to 0. When you ever have a equation like this, which is a quotient, it's the top bit that matters. The bottom bit, so long as it's not 0 itself, doesn't matter. So we can just say this is not possible. You can either say t squared equals to minus 2, impossible, or you can say t squared greater than or equal to 0, so t squared plus 2 is greater than 0, so it's not possible. Whatever, you just say there's no real root, anything like that, but we do need to explain, so therefore there's no stationary points. Okay, now the third bit would be quite tricky because it's a relatively, because we've got x, it's right at the parametric equation. Because we've got x and y in terms of t, and t occurs twice, this would be quite difficult. You know, you can imagine trying to get t the subject is going to be pretty hard, because that's going to end up with a quadratic. It's going to be quite messy. Thankfully they've given us some help. So they're saying by considering x plus y, so we better do that. if we do x plus y, look what happens. We've got t plus 2 over t plus t minus 2 over t. Those two bits cancel here, obviously, plus that and minus that. So we end up with x plus y is equal to 2t. That's kind of brilliant, because that's what we want. We want t to substitute. Doesn't matter whether we substitute it in here or we substitute t in here. Really doesn't matter, so long as we go with it and do it properly. It does say it doesn't want fractions or brackets in our answer, but we should be okay now. We've seen that. So we've got t is equal to x plus y over 2. And we've got to substitute for t into this equation. I say it wouldn't matter if it was the other one. So we got x is equal to x plus y over 2 plus 2 over x plus y over 2. Right, okay, so it wants us to get rid of the bracket, so there is a little bit of messing around to do. I might get rid of the stack fraction here first, I suppose. So we could write x is equal to x plus y over 2 plus 4 over x plus y. And then I might just times by to get rid of the fraction. I might put times everything by 2 times x plus y. Everything, including the left-hand side, right-hand side. So here I would have x times 2x plus y. Here I would have x plus y squared, because the 2 would cancel. That would come to x plus y squared. And here I would have just 8, because the x plus y would cancel. That would come to 8. Doesn't want brackets or anything like that, so let's multiply out. 2x squared plus 2xy is equal to x squared plus 2xy plus y squared plus 8. The 2xy occurs on both sides, so that cancels. Oh, and I've forgotten the 2x squared there. I don't know if I said there's 2x squared there, obviously. But that bit cancels. So what I get if I take the x squared and the y squared over, I get x squared minus y squared equals to 8. For though it's not on the course, but that is actually a hyperbola. There's a whole class of these curves. It looks like this. It's basically like it's like the y equals 1 over x curve rotated 45 degrees, but that's not on the course. So anyway, that's it. Not bad for question 10, but I think it was a bit tricky at the end to get the equation they're looking for. There we go. So that's it, and there will be more videos to come on parametric shortly. Thank you, bye.